Hello and welcome to another one of DZDD videos. Today we're going to be doing the Lewis structure for the simplest aldehyde formaldehyde, CH2O. So, as always, the first step is to add up all the valence electrons. And if you just look on your periodic table, you can get the group for hydrogen is in group 1, carbon is in group 4, oxygen is in group 6. So as a result, we have 4, 1, and 6 for our number of valence electrons. The number of atoms, it goes here. Then you multiply these two columns to get what goes there, the total number of valence electrons will then be added up, that final column, and you get 12. So we got 12 electrons to work with as lone pair electrons and bonding electrons. So first what we're going to do is draw the skeleton structure. Even though hydrogen is the least electronegative because it has one orbital, it can only hold its single unpaired electron and form one bond. Carbon is the next least electronegative, and in this situation, in most situations, prefers to be centered. All right, so we're going to draw the bonding electrons. Each line is 2 electrons. We're going to subtract the bonding electrons from the total number of valence electrons to determine how many lone pair electrons we have. Okay, so we start off with single bonds everywhere. I want you to keep in mind that carbon doesn't look like it has a full octet, but we're just going to go with it. Let's pretend we didn't notice that. And we're going to have 12 total valence electrons minus 2, 4, 6 bonding electrons. Gives us 6 lone pair electrons. All right, so once we get that sorted out, what we need to do is draw in those lone pair electrons. So we're going to put 2 on carbon to satisfy that octet. Okay, so it has 8 electrons around it. And then here, oxygen gets the remainder. So if we were to then calculate the formal charges, for the formula, we're going to still use valence number, which is the group number, minus the number of bonds, plus the lone pair electrons. So for instance, if we look at carbon, carbon's valence is 4, and it has 1, 2, 3 bonds, plus 2 individual lone pair electrons. Hydrogen, 1, group 1, minus the 1 bond it forms with carbon. Don't count the other one. It's just this type of hydrogen. This formal charge applies for each one of these. Formal charge of oxygen, it's going to be 6 is the group number, so 6 valence electrons minus 1 bond plus 4 lone pair electrons gives me a plus 1. So the net charge does work out. This is a valid Lewis structure because -1 plus 1 is 0 and formaldehyde is neutral. There is no charge there. However, we've got a bunch of formal charges. It's not too stable, -1 and 1. And carbon has a negative charge. All right, carbon rarely ever has a negative. Oxygen prefers negative charges, if any. It's very electronegative. But here, we don't have that scenario. So what we're going to do is we're going to try to redraw it, but we're going to draw it with an extra bond. And when we draw this extra bond here, carbon now has a nice octet because 4 minus the 4 bonds and 0 lone pairs gives me a 0 charge. Oxygen, 6 minus the 2 bonds plus 4 lone pairs gives me a 0 charge. And then hydrogen, 1 minus 1 bond gives me 0. All right, so you can see that we've got a lot fewer charges and we have more bonds. So this is the preferred structure for formaldehyde. All right, what you'll see is the structures will alternate between the Lewis structures we have, but the more stable one always has more bonds and fewer formal charges. So I hope that clarified things a little bit and you were able to understand Lewis structures just a bit more, enough for you to practice, gain a little courage. But the best way to become better at this, just like I say in just about all my videos, is to practice, practice, practice. That's the only way you're going to get better at this stuff. Check out the advanced video. I also will have a series of videos for Lewis structure of ions. Check those out. And thanks for watching. And as always, have a great day.